area. What is area? Let's write the definition and then talk about it. So, the area of a figure, is the number of square units. You could write that as units squared like that. So the number of square units inside a figure. So our job is really to cut up the figures into tiny squares, count them up. Now obviously we're going to find the best way to do that. Wait, let's write down, what does a square unit look like? Well, one unit is just a length, like, you know, a length of 1. What does 1 unit squared look like? I kind of gave it away. It's a square that's 1 by 1 by 1. That's 1 square unit. So if I said the area was 20 square centimeters, it would be 20 squares that are all 1 centimeter by 1 centimeter. Okay? So let's look at different shapes here. Let's look at a rectangle first. Probably the easiest one to cut up. Right? If you draw a rectangle, let's say it's 2 inches by 5 inches. Okay? You could kind of divide it up. If this is 2 inches, so maybe here, that's 1 inch, 1 inch. So you could kind of cut it here and cut this into the 5 inches. 1, that's going to be too big. 2, 3, pretend those were equal. Okay? So those were each an inch. Now you've got all 1 inch by 1 inch squares. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's an easier way to organize and get 10? You know there's 2 this way by 5 this way. Couldn't you just do 2 times 5? Yeah, and that is why the formula for area of a rectangle is just base times height. Or length times width, that's fine. You can write that there if you want. Okay, so you can start with either one of those formulas and plug in what you get here. 5 by 2. So that's 10 square inches. And really, if we had written in 5 inches by 2 inches, an inch times an inch is an inch squared, right? That has an exponent of 1. Remember we did the laws of exponents? Inch times an inch would be inch to the 2nd power. That's how it works out. Look how math works out. So nice. Okay, so any rectangle, base times height. All right. Second shape we're going to do is a parallelogram. What makes a parallelogram? Well, 2 pairs of parallel sides. So actually, a rectangle is a parallelogram. It's just special because it has 4 90 degrees. Okay, let's draw a parallelogram. Okay, and I'm going to give us some numbers here. Let's say this is, I don't know, 8 inches, 4 inches, and I'm going to drop this down 5 inches. Okay, now how would we cut this up into squares? I'm actually going to pause it and show you guys a little magic demonstration. Okay, I hope you enjoyed that. So if now we know it's just base times height. Now which is the base and which is the height and which number aren't we going to use? So the base and height, guys, are always going to make a 90 degree with each other. Okay? So in this case the base is 8, the height is 5. We're not going to use the 4 for area. Alright, multiply those together, and there are 40 square inches in that shape. Okie doke. All right, let's look at how to do a triangle. And I'm going to start with a right triangle. Let's say this is 3 feet, 4 feet, and 5 feet. Okay, now how would we figure out how many squares in there? Actually, if you think about it, if you could picture the rectangle, the 3 by 4 rectangle, you could count all those squares, and then you really want half of that, right? This triangle takes up half of a rectangle. Well, that's really true for any triangle. So the formula is you take the formula for a rectangle and you cut it in half, divide it by 2. So that is your formula for every triangle. Okay? So now what are the base and the height? Just like before, same rule. They're going to make a 90-degree angle with each other. So it's looking like the 3 and the 4. So that's 12 over 2. There are 6 square feet in that triangle. What if I gave you a different looking triangle? How about this? Put a point here. That and that. And let's say this is 8 feet, 12 feet, 15 feet, and see there's nothing making a 90 here. I would have to drop down and tell you how tall this is. Let's say that is, gosh, I don't know, 10 feet. Okay, so you see a triangle, you still start with that same formula. So base times height over 2. Question is, what are the base and height of this triangle? I guess this would be your 90 here. So 8 and 10. I know 10's not even part of the triangle, but you need to know how, I guess, how tall it is, the height of it. So you're going to use that 10. So that's 80 over 2. That's 40 square feet. What kind of triangle is that? That looks like an obtuse scalene. Okay. All right, so that's triangles. What else? There's one more shape that you need to have memorized. So you are going to have to memorize these shapes here. There's one more that you have to have memorized for today, and that is a trapezoid. And a trapezoid has one pair of parallel sides. So what does a trapezoid look like? The classic one looks like this. Here's your one set of parallel sides. They connect. But technically, a trapezoid could look like this, right? Because there's your parallel sides. Really, you could start with parallel sides and then just connect them in any way, and you would have a trapezoid. Okay, so let's look at the classic one here. That's the most fun. And if these two sides on the side here are equal, it's called an isosceles trapezoid. Let's make an isosceles one. Let's say this is 6 centimeters, 5 centimeters, 8 centimeters, and they're going to drop down a height and tell you that's 4 centimeters. Okay, now I kind of want to show you how you come up with the formula, because it'll help you remember it. So if I actually cut this from corner to corner, do you see what I created there? I created 2 different triangles. Okay, and I'm going to put some labels on these. I'm going to call this base 1, base 2. This is the height. Okay, that's pretty much what you need here. So if you didn't know the trapezoid formula, you could actually figure this out, because you could figure out like this is one triangle, this is two. You could figure out for triangle 1, you would do base 1 times how tall it is and divide it by 2, right? That's triangle. And then you could add it, let me get rid of this. You could add it to the other triangle, which you would use the base 2, same height. So really you could do that every time. If you wanted to just find the area of both triangles, add them up, that would work every time. The real formula for a trapezoid is we're going to kind of undo this. What do these both have in common? They both have the h, they both have the 2. So you can kind of pull those out front. The h is here, everything's divided by 2, and then base 1 plus base 2 is together. So if you were going to distribute this h, you would get back to here. But this is the formula for area of a trapezoid. But either way would work. I would accept either technique here. So let's use that formula and fill in some numbers here. So what's the height of this shape? 4. And does it matter which one is base 1 and which one is base 2? No. They're just make sure the bases are on the parallel sides. So 6 and 8, you pick which order. So that's 4 times 14 over 2. That's, that's not right. 4 times 14. Looks like I have a mistake. Yeah, 56. Hello. Over 2. 56 over 2 is 28. What did we have here? Centimeters squared. And there you go. All right, good. So those are all the shapes that we're going to learn today. The last thing I want to talk about is if you have what's known as a composite figure, which basically just sticks a bunch of different shapes together. So, I don't know, something like this was number 5. And, you know, like that. Boom. Looks like a house, right? So if they wanted you to find the area of this figure, let's put some numbers on here. 6 feet, and I'm going to say these are all the same. And let's say these are 5 feet, and that's the same as that. And I'm going to tell you the height of the whole figure is 10 feet. So what would your strategy be here for figuring this out? Well, you got to find the area of both shapes, right? And I want you to stay organized. So here's what I want you to do. I want you to, in the actual figure, label it with numbers and put a circle. Then when you do your formulas, I want you to use a subscript. Sub means under. So area of section 1. Well, what is section 1? It's a square. What would the formula be for that? Base times height. What are the base and height of the square? 6 by 6, right? So 6 by 6. So the square is 36. You can put the units. Then the second section is a triangle, right? So what is the formula for that? Base times height over 2. Now what are the base and height of that triangle? I know the base is here, that's 6. But what's the height? It's not 5. 5 is at a slant. Remember, the height should make a 90 degree with the base. So can we figure out that distance right there? Ooh, we know the whole distance is 10. And we know from here to here is 6. So what does that leave for that section? That's got to be 4. Okay, so there's no guessing. There is a reason that that is 4. All right, so area of section 2. 6 times 4 is 24. that's 12 feet squared. And then for your total, T for total, you would just add those together. So 36 plus the 12, and you're up to 48 square feet in that figure. Okay, so stay organized, use a formula, substitution, answer with units every time, formula, substitution, answer with units.